Hi, hello, GATE 2025 aspirants. We are preparing for GATE 2025. For this, the first subject is control systems. Coming to the control systems subjects, what is system? System means transferring energy. We know the law of conservation of energy. The energy is neither be created nor be destroyed. Energy is transferred from one form to another form. That's okay. Signal, coming to signal, it is the energy used to convey the information of any phenomenon. Okay, you can understand, it is the energy used to convey the information. Energy used to convey the information, to can highlight that point of any phenomenon. Okay, coming to the block diagram, next one, we can take example as a fan. Okay, system is, there is system, there is fan. We can give input signal. What's the input signal? Input signal for the electrical power. We can give input as the electrical. So power of electrical power equal to voltage into current, and system is fan. The desired output is mechanical power. So the fan should be rotated. That's why mechanical power. Mechanical power equal to tau into W. Tau is torque, W angular speed, W equal to angular speed. So we can call input signal or excitation or forcing friction or cause or through variable. We can call other names, the output signal or response or effect or across variable. That's mathematical expression of the signal. Function of one or more number of independent variables. That's a mathematical expression of the signal. Definition: control system is that means by which any quantity of interest is to maintain according to the desired manner. Okay, I can say another definition for the control system. Control system is that means by which any quantity of interest in a machine, mechanism or other equipments is maintained or altered in accordance with a desired manner. There is the control system block diagram. We can see this one as the ideal control system. In this ideal control system, we give command or a reference input or desired output. We give controller that is actuating signal. For this controller we give command. For the next is plant or process, we give that actuating signal. It's come control output. The control output is also known as desired output. Coming to the practical control system, before we discuss the ideal control system, this is the practical control system. In this practical control we see some difference. There is a sensor. Okay, we see the block diagram. There is first error detector, controller, plant. For this plant only we kept, there is a disturbance occurred at the plant only, we have to highlight that point. We have to see once okay, then the sensor or feedback element. Feedback is connected to the error detector. For there is a command for error detector, and there is an error signal and connected to controller and actuating signal. Plant control output, the output is connected to error detector through feedback. This system can overcome the effect of disturbance associated only with the plant only, whereas other disturbances still continuous, which means that is possible to obtain steady state, but it is impossible to obtain 100% output in the steady state. That is the practical control system and is closed loop control system. That is the advantages of the closed loop control system is accurate and reliable, reduced effect of parameter variation, reduced effect of non-linearities, Coming to the disadvantages of the closed loop control system is the system is complex and costly. System may become unstable. Gain of the system reduces with negative feedback. That's a disadvantage. Coming to the applications, we use it as the electrical iron, DC motor speed control, tracking system, autopilot system. That's it. Coming to the open loop control system, here we see the two cases in this open loop control system. We saw the case one. In this open loop control system, there is a sensor feedback which is in open loop, not connected through plant output. See the one's diagram. This is the first case, and I will show you the second case. This is the second case. We saw that there is a feedback connected to output and the feedback is not connected to the error detector. This is the one of the open loop control system. We saw that open loop control system. For this, the advantages of open loop control system, it is simple in construction and design. Its cost is less and money to maintain. These systems are convenient to use when output is difficult to measure. Disadvantage: inaccurate, unreliable. The effect of parameter variation and extension noise is more. Coming to the applications, traffic light controller, electric washing machines, automatic coffee servers, bread toasters. Coming to the difference between open loop control system and closed loop control system, here we see the differences. First one is open loop control system, closed loop control system. Not coming to the open loop, I say first open loop and next closed loop. Not accurate because it either has no sense or partial sense. Coming to closed loop control system, accurate because it has complete sense. We saw in diagram also. Coming to open loop, it is slower because its time constant is more large. It is coming to closed loop, it is faster because its time constant is small. I would like to say here one example. We can take washing machine. In this open loop control system, we can take manual or washing machine. In this closed loop, we can take example as the automatic washing machine. In this manual, we have to, there is the three: wash, rinse and dryer. We have to stay near the washing machine until the process is done, because it is manual. We have to kept your clothes in the dryer. Resign, we have to apply anything. In this automatic closed loop system, automatic washing machines means no need to be stay there. It's automatic. That's the one. That's why time constant, we see there is time constant. More sensible, less stable. In open loop, less sensitivity, hence more stable. Coming to open loop, simple and economical, complex and expensive. Open loop, generally stable but cannot be stabilized. It becomes unstable. Generally stable but be stabilized, it becomes unstable. This is the main difference between open loop and closed loop control. Next we see the important points. Here we see that by default control systems are closed loop control systems. By default feedbacks are negative feedback only. Here we see that in this open loop control system, it does not having sensor but it sends the error. See the difference, those two differences. In the closed loop control system, it is having sensor but it does not sense errors. That's a both. We can see the differences of open loop and closed loop. We can call control systems as closed loop control systems, and most we refer only negative feedback only. That's all for today. See you in next class. Bye.